Okay, so far we've talked about like collecting data, which was like the first module, and then the next two modules, modules 2 and 3, was called summarizing data. No, I'm sorry, it was called organizing data, where you made the graphs, we read graphs and different things like that. Now we're on to summarizing data, and this is where we can do a bunch of stuff, because this is all dealing with quantitative numbers. So what we look at, they have them in different measures of center, measures of variation, and measures of position. The measures of center are the ones that you know, so today shouldn't be that bad, and then we'll go into the variation one on Thursday, right? And it may be a little bit different, a little bit hard. I think I took out some of the hard stuff, but so a lot of this you've heard before, but there are some that get tricky. So to start, find the average of two numbers. This is something we will need. I guess it's got my answer right there, but to find the average of two numbers, you always just take them and add them up and divide it by 2. So this would be, I guess Apple can solve it for me. This would be 30 divided by 2, which is 15. So, 15 is in the middle of 18. So we will do some of that when we get to like the median, when we talk about the middle of numbers. Summation notation. So this is, I think this is like the one. Hold on, sorry, I don't want to do something that I don't think they go as hard as my AI stuff made it. Let's just do this one. Okay, so summation notation. This is a symbol right here. This summation, this is like uppercase sigma. Okay, so this right here, is uppercase sigma. It means to sum or to add. As soon as you see it, that's what it means. The reason you do this is because y'all can probably answer this question. How do you find the mean? Somebody can answer it. Nobody? The average? How do you find the mean, the average? Same thing? Thank you. Add them all up and divide by how many there are. So sometimes in like these formulas, like to find the mean, they use a formula of like, okay, you do the summation of the numbers divided by how many there are. So it is a symbol that you will see. I'll go ahead and tell you this because we will start using the calculator right now, or in this section. If you ever do anything in this class that takes forever by hand, stop and email me or something, okay? Our job is not to do statistics. Our job is to interpret statistics. Technology does all the statistics for us. So there should never be anything in this class that takes you a long time to do by hand. If you're doing something a long time by hand, there's an easier way to do it, okay? So the Alex calculator will do a lot of this for us. There's only like one formula that I can't find a way to do, but once we go over it, it makes sense. So we will use the Alex calculator. So on this one, this is a summation. These numbers right here, how do I say this? These kind of like count how many numbers you're adding up. Okay, so that's a count. It's saying you're going from, these say you're going from 1 to 5. So you're going from the first number to the second number to the third number to the fourth number to the fifth number. Okay, so like it would be x1 plus x2 plus x3 plus x4 plus x5. So that you can see it says I equals 1 right here. So you're just changing that number all the way 1 to 5. So that tells you how long you're adding up. So that's kind of what the summation means, but all you're doing here is 18 plus 14 plus 13 plus 15 plus 20. You can do that in the calculator in Alex. I don't think there's like a shortcut way. I was trying to do this real quick in my head while I'm talking. 48 plus 32 is 80. Okay. So on this one, the very introduction stuff, sometimes they won't let you use the calculator, which is kind of a pain, but it is just introducing you to some of these different ones. There's one more I got to do, I think, in that section. So in the calculator right here, there is actually a summation button, but it is missing from this right here. You go like the blank spaces right there. because they want you to do it one time by hand before you actually start using the calculator. But after you get done with this topic, that'll be there, and I'll show you in just a minute how to do that. If you know how to use Excel, you're welcome to like send this data to Excel. Like if you send it out to the calculator, that's useful, but there is no sum button, so that doesn't really help us. You can send data to Excel. I'm not going to do that right now on my iPad, but if you know how to use Excel, you're welcome to do that. If you want to learn a little bit of Excel, I'm happy to teach you to do some of that. This is the other one. So this one's just a slightly different that you may see. This is like if you're doing standard deviation, which we'll talk about on Thursday by hand, but we are not doing that by hand, but that's fine. They do this variation. So this one has a squared right here. So what you're actually doing on this one is you're doing x, the first x squared plus the second x squared plus the third x squared plus the fourth x squared plus the fifth x squared, okay? So what you would have to do on this is go, what are my numbers here? So you do 18 squared plus 9 squared plus 8 squared plus 11 squared plus 6 squared. And again, I think this first time there's not really a shortcut on this. That is kind of a pain. Y'all are going to have to help me on this one. Somebody add these up. I guess I got my phone right here. So you square each of these numbers. I think there's a shortcut way of doing that, but I can't think of what it is. 324 plus 81 plus 64. What?
626.
626, thank you. 626. Okay, so that one you have to square it before you add it because it says squared right there, okay? So those are the two different variations of that problem. And again, this is kind of like the basics of doing the formulas, but we don't really do the formulas in this class. To find the mean, you add them all up and divide by how many there are. I am actually going to go to the actual topic because I want to use a calculator. So this is the mean. The group of 6 students asked, how many hours did you watch the last television week? So the mean is the same thing as the average. That's a fancy stats word for average. It is talking about the center of data. The average is usually somewhere towards the middle. We'll talk a little bit more about that when we get going here. But to show you how to do this. So there is a button normally right here on Alex, right there, but it is not there because, again, this is the first topic that they want you to do. Stop it. I got to zoom back out. Okay. So if you click send data to calculator, we said it a second ago, the way you do, I'm telling you the easy way to do it even without the button. When that button comes back and we're trying to find the average here in a couple weeks, you just hit the average button and it'll give it to you. But they took it away for now. But we just said to find the average, you add them all up and divide by how many there are, right? Well, this sum button, we just learned that. You add them all up. You click that sum button right here, this sum button right here. Oops, I don't want to click it again. Send data to calculator, sum. That adds them all up for you. So that does that last topic in like 2 seconds. And then we're going to divide by how many there are. So there are 6. And that will give us our answer. I'm actually going to go back just a second. Can I highlight all that? Will it let me? Divided by 6, just so I can take a screenshot of this and show you, okay? So that is our answer. What was the answer? 13.167. This is the easiest way to do it. So you can use that summation button right there, and that adds them all up. And then you just divide by how many there are, and that makes your life a lot easier, right? So let's write a couple things here so we have it when you go back and look at it. That is, adds them all up. And then you have to divide by how many numbers there are. Okay? What I say the answer was, I don't even remember now. 13.167. Was it 167? I think. That's fine. Okay, so that is the easiest way to find the mean on those is to use a calculator. So make sure, like I said, anytime for the rest of class, if you find something that you are taking forever to do by hand, stop and don't do it. Ask me, ask somebody, because there is an easier way to do it. Okay, you can do different things with the mean. Like you can figure out if you need an average test score of like a 75, you can figure out what you need to get on your final to get that score or whatever like that. So on this one right here, it says a basketball team has a mean of 53. The total number of points they scored is 954. How many points have they scored? So if we know they scored a total of 954 and they have a mean of 53, that will tell us how many games they have, right? So 954 divided by 53 is 18. So they have played 18 games. I thought there was one that was harder than that on that section. Let me refresh another one real quick. Okay, it doesn't look any different there. This is the one I was thinking of. My bad. Finding the value of a mean. Do they have a good problem here? Nah, we'll just do the Alex problems. I've kind of gotten bad about doing the Alex problems instead of the AI problems, but I think in stats it works better. In algebra, I think it's fine, but... All right, Martina has scored. So this is a scenario like that you would actually use. So Martina has scored a 71, a 78, and a 66 on the previous 3 tests. What score does she need on her next test so that her average is 71? Okay, so what you need to do first is figure out how many total points do you need if you have, so you have 4 tests and you want an average, you want a mean of 71. Stop that. Okay, so if you have 4 tests and you want a mean of 71, then you need 284 total points is what you need, right? But you've already scored 71 and 78 and 66, so you can just subtract all those from there. You could add them up and subtract them either way. I need at least a 69 to get the total amount of points that I need to get that. So you can add up all the points you have already, but you got to figure out how many total points you need in order to get an average of 71 on there first, okay? So this is what you can do. This is something that you would actually use as a student. Actually, y'all don't even use that anymore because you can do the what-if scores on Canvas, can't you? You don't know what I'm talking about? All right, the next one, there's not that many topics today, I don't think. How many are there? Anybody know? What'd you say? No? I'm kind of flying right down the list. The next one is the hardest one in the section. I'm just guessing that this is the hardest one in the section. So, you all know when I talk about the mean, y'all knew how to find the average. You add them all up and divide by how many there are before I even got going on this. This one right here is the hardest one because everybody kind of generally knows what the average means. When you start to think about it, it does make it a lot harder. So this one says a job placement agency advertised that last year its clients on average had a starting salary of $39,000, okay? So we kind of know, okay, if I go start working at this company, I'll make about $39,000. That's the way we think about the average. It's the middle number of the salaries. Some people make more, some people make less. It averages out to be $39,000. There are 2 scenarios for the average to come out to $39,000. Okay, the first scenario is all the numbers are $39,000. Okay. What I mean by that, and I'll probably erase this now, I'll leave it. What if everybody in the company made $39,500? My average would be $39,500 if everybody in the company made $39,500, right? That's a scenario that nobody thinks about, okay? The other one would be some lower than 39,000, some higher than 39,000, and then the average just averages out to be 39,500, right? So that is my two scenarios that make the average be. That's like the only two possible ones. Are either every single one of them is 39,500, or you got some lower, some higher. Some could be equal to 39,000, but there's a mix and it just averages out to be that. Okay. So as we go through you got to keep those two scenarios kind of in mind because those are possibilities. So it says last year, fewer than half of their clients had a starting salary of 39,500 or less. What word do we associate when we hear half? Mean and anybody? Median, thank you. So the average does not tell us a half. This would actually be more like the median, okay? Because if we took all of our salaries from this year, how much money we've made so far, and then we put, I don't know, Elon Musk or Jeff Bezos or one of them sitting right here, then we could go tell everybody the average salary in my class is like, I don't know, 10 billion or whatever stupid number they make now. Because that one number would pull the average really far up, right? So like one number, like you could have one number above the average and we all be less than making 10 billion a year. So, or if you're making more, let me know so I can borrow some money. But that one number would be the only number above the average, all of us would be lower than the average. So the half only has to do with the median. It has nothing to do with the mean. Last year, at least one of their clients made a starting salary of exactly 39,500. This is going to be false because some could be higher, some could be lower, and it just averages out to be that, right? Okay, so you don't have to be exactly that. Some could be higher, some could be lower, and it could be average out, be that. At least last year, at least one of their clients had a starting salary of more than 42,000. Not necessarily, because what if they were all exactly 39,000? The average would still be 39,000. Okay. This one's a trick one. 2 years ago, some of their clients had a starting salary of at least 39,500. You have to make at least 39,500 for the average to be 39,500, right? So that's true, but why is this one false? Anybody? Did somebody say it? Nobody? Y'all are quiet. The problem says last year. This problem says last year it's clients. That's the only data we know about. This says 2 years ago. So it's true, but they used the wrong time frame. So that is a very tricky question. Do not miss that one. That one is on every single iteration, okay, where they give you the wrong time frame. Last year, all of their starting clients had a starting salary of 39,000 or above. What's wrong with that? It's not going to be all. Somebody had to make less than, or it's possible. I'm sorry, I guess I shouldn't say somebody had to make less than. It's possible that somebody made less than. So my answer on this one is actually none of the above are true. Okay? That is what makes this problem hard to do because sometimes it's one of those, sometimes it's two of them, sometimes it's none of them. Let's do one more just to walk through it real quick. So what do we got? Last year's clients on average made an 8% profit. So last year, at least one of their clients made an 8% profit. It was exactly. No, you can make less than 8%. You can make more than 8%, and it just averages out to be 8%. Last year, all of their clients made a profit of 8% or more. Nope, not all of them. Like somebody had to make less than 8%. Last year, fewer than half. I can already stop because mean has nothing to do with half. This year, I can already stop because this data, all we know is stuff about last year. We don't know anything about this year, right? Last year, some of their clients made a profit of more than 5%. That would be true because somebody had to make more than 5% for the average to be 8%, right? So this is how you do that one. It is not a fun one to get by, just because, like I said, sometimes it's 2 answers, sometimes it's 3, sometimes it's 0. But that is the point of y'all taking this class, is kind of to learn how statistics are used and different things like that. So I do like that topic, even though it's hard. Weighted mean. This is how y'all do your grades, kind of, or how you should do your grades. If you're figuring your grades by hand, the following summarizes the number of fiction books I read last summer of 38 students. Find the average. Okay, so what this says is that you have 4 students that have 2 books. Okay, so I could write these numbers out and say this is like 2, 2, 2, 2, right? One student has 2 books, another student has 2 books, another student. This one would be 9 students. Oh my goodness, that's a lot, right? That'd be like 9 times. 4, 5, 6, 7, 8, 9. So I could write all those numbers up and then find the average, right? But that's going to take a long time. So what the easier way to do, I'm not doing that one. That's a lot. 15. Okay, I was going to write them all, but 15. So the easier way to do is you can do 4 times 2 is 8. And you can do 9 times 3 is 27. 15 times 4 is 60. And 10 times 5 is 50. And now add all those up. So that's 110, 137, 145. And then now that's my total number. So 145 divided by the 38 students. And it would be 3.82. All right, 3.82. Okay. So this is the easiest way to do it. If you look, the reason you can do that is because if I did 2 plus 2 plus 2, that would be 8, right? Or if I did 3 plus 3 plus 3 plus 3 plus 3 plus 3, 3 plus itself 9 times, that would be 27. That is the same thing as multiplication. So what you do, or the way that I think about this, is you multiply the rows, and then add them up and divide by how many there are. I'll leave those examples there. What do we got next? Problem 8, median. We'll do these right here. Okay. So when you do the median, the number one step is to sort least to greatest. Okay. So y'all know the median is the middle number. I know most of y'all know that. So use the Alex calculator actually for this. Okay, there is a sort button, the median. So you can send out at a calculator and you can sort it. So that does help you do this, okay? I'm just going to put this here real quick. Sort. Okay, so that's the number one step, is to sort it from least to greatest. So we know, I guess we should have defined median first. I'm just assuming we've already said it a bunch. So y'all know this, but we'll go ahead and write it right here since this is technically the first time we talked about it. Did it do it? Why? This new update is making me mad. Try it one more time here. I just want to move that down. Okay, I'll just write it at the bottom then. Fine. The median is the middle number, okay? All right, so number 2 step is find the, so we write them from least to greatest. So I'm using those numbers up there, 3, 7, 9, 12, 15. So to find the middle number, you can just kind of like count off whichever way you want to do that. One from the left, one from the right. So my median right here is 9. Okay, y'all know how to do that part. What happens if your middle number? So first of all, I got to line them from least to greatest, right? 4, 6, 8, 10. So when I start doing the middle number here, I'm not going to have a middle number. So my middle is actually right here. This is actually my median. So that's where we do the very first topic that we did today. You have to find the middle of those two numbers, which is 7. Okay. So if you're what's the rule there? If you have an even amount of numbers, your median will be in the middle of two numbers. So add them up and divide by 2 to find the middle of those. That's a long sentence. But y'all, I think most of y'all have seen that before. The mode, I guess, again, we will write this out since I think we mentioned this the other day in class. But the mode is the one that occurs the most. Okay? The one thing I will say is that you can have one mode. Like if you had numbers like 2, 4, 4, 6, 8, okay? The mode would be 4. You can have two modes. If you had numbers like 2, 2, 4, 6, 6, 8. Wait, I shouldn't say two modes. I should say multiple modes. Okay, so the mode here would be 2 and 6 because 2 and 6 occur more than any of the other numbers, right? 2 and 6 occur more than any of the other ones. You can also have 0 modes. If I had, this one's the one that kind of confuses people, 5, 5, 7, 7, 9, 9. So 5 and 7 and 9 both occur twice, right? But do any of the numbers occur more than any of the other numbers? None of them occur more than any of the other ones. So this is no mode. Okay. So like my mode on this one is obviously 4, right? My mode on this one, I know it's just written there. It's kind of hard to see, but 3 and 5. When I go to Alex, I will show you this. Not that it's like super necessary or anything. But you can send data to calculator, and if you sort it, it's really easy to tell what my mode is. So like this one would be 4, right? 4 occurs 3 times. So let me write that real quick here, and then we'll move on to the next topic. Use Alex calculator, the sort button. Calculator, sort button. Help see it. I think I forgot a letter here too. Okay. Next one, mean median mode computations. All right, so this one's just kind of putting all 3 together. To inspect a manufacturing process, companies typically examine samples of parts for deficiencies. One company that manufactures ballpoint pens selected samples of its manufactured pens on each of 10 days. The company recorded the following numbers. Okay, so send data to calculator. First thing I need to find is the median. So if I sort this, you can't make the calculator bigger, which is really annoying, to tell you the truth. I really wish you could, but you can't, and I don't even know if on my iPad I'm going to be able to get it to work. So, what numbers are smaller than 12 right here? There, I went to the side there. Okay, so if I have 10 numbers, my middle should be about the 5th one. If you need to write them out and cross them off like I was doing a second ago, that's fine. Is that all 10 right there? 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't get all 10 on the screen. There's 3 20s. Okay, so 1, 2, 3, 4, 5. My middle is going to be right here, okay? So if I have 10, my middle is going to be 5. My middle is going to be right there where my cursor is. If I have 17 on one side and 17 on the other side, then my middle is going to be 17, right? That makes sense to everybody? If you need to add them up and divide by 2 since it's in the middle, that's fine. 17 plus 17 is 34. 34 divided by 2 is 17. The mean, the way I would do the mean for this, I'm going to send it to the calculator. I'm going to hit this button right here, the summation button that adds them all up, and then divide by 10 to get my answer. That's 16.2. The mode, it does give you options there on the mode. I'm going to sort it just to see, but I have 23 times and I have 17 3 times. So there are 2 modes. There is 17 and there is 20. Easy enough, right? Kind of. Quickly, right. So for this one, you could use sort. This one, you could use sort. And then on this one, you want to use the summation button. Just a couple left. How changing 3 left. All right, so this one does mess with people a little bit on this one. The number of trading cards owned by 10 middle school students is right there. Suppose that the number 395 from this list changes to 565. So first of all, are these in order? They are in order, right? Okay. So what happens to the mean? I'm about to write these on the board or something. So to find the mean, I'm going to send it to the calculator. I add them all up by clicking that button right there. Let me just do it again so I can hold it and make sure you see it. The summation button right there, enter, and I divide by, not pi, divide by 10. So my original mean is 527, okay? My new mean, what I would do is I'd just click this undo button and undo. Well, you can clear it if you want to. What happens if I change this 395 to 565? So I need to change this number right here. No. I can't get. Hold on. My keyboard's not popping up there. So I can't backspace. Okay, so if I change that 395 to 565, what's going to happen with my mean? So if I just change that in the calculator, now what you got to do is make sure you highlight all of these again. Okay, make sure you highlight all of these because if you don't, they won't go back into your thing. Actually, you know what I'm going to do? I'm going to send data to the calculator. I'm going to hit the summation button first, and then I'm going to go change that number. So 395, I'm changing to 565. And then I need to divide that by 10. So that is 544. So it went from 527 to 544. So 544 minus 527, it jumps by 17. So I increased it by 17. Okay. What was it, 544? Yeah. Let me write this out in just a second. What happens to the median? Okay, well, let's find the median here. So the first thing I need to do, they're already sorted. Actually, I'm going to just write this out because this would be easier to write out because they're already sorted for us. All right. So if I'm looking at the median, there's 10 numbers, so my middle is going to be right here, right? So my median, the original median, I'll say, the original median is 528 plus 541 divided by 2. That is 534.5, okay? That's my original. My new median, I've now changed it. If I change this to 565, that's going to change my my order, isn't it? Because now I have 476, 506, 507, 528, 541, 555, 565, 573, 588, 601, okay? So now my new median is going to be 1, 2, 3, 4, 5. It's going to be right here. So I do 541 plus 555 divided by 2. That would be 96, so 548. So that's my new median, and that's my old median. So what's 548 minus 534.5 is 513.5. So it's just 13.5. It increases by 13.5, all right? So you have to find the original and find the new and then find the difference. Now, the point of this topic is they have a word that's called resistant. And the mean is not resistant and the median is more resistant. Let me write this out real quick here. So resistant is kind of like how a number changes based on a really small or big number. Okay. So if I introduce a small number or a big number, like if I had Jeff Bezos sitting right here, our salary would change a bunch, right? Because our average salary would change a bunch. The mean is not resistant. Because if I put one big number in or one small number in, it's going to really change my average, right? If y'all took a test and everybody got a 90, but one person got a 5, that one grade is going to bring the average down a bunch, okay? The median is resistant because if y'all got a 90, if a bunch of people got a 90 and one person got a 5, my median is still going to be in the 90s because the middle of that is still going to be in the 90s. So the median usually doesn't change as much just when you change one number. So that's kind of why you are doing that topic right there. All right, 2 more topics, right? This is taking a little longer than I thought, but it's just all the drawing and stuff. There's one more thing I need to do too. All right, so this is choosing the best measure, okay? So the following number of people attended the last 9 screenings of a movie. Which number should be used to summarize the data? If there is one, so like these numbers are all 195 to 209, right? There's not a really big number. There's not an outlier. Like an outlier is a number is really far away. We'll talk more about that in a couple of days. But so this one is going to be the mean because those numbers are all close together. If I look at this one, it's like 28 to 38, and then all of a sudden there's an 86, okay? So that one big number is going to change my average a bunch. So what I want to use for that is the median because I don't want that one big number to affect my numbers. The real life scenario of this is like when you go later on in life, when you go buy a house. If you're going down this neighborhood and you have all these houses that are $200,000 that are like 2 or 3 bedroom houses, and at the end of the street there's like an 8-bedroom, $700,000 house. You don't talk about the average house price in there because that one house at the end of the street is going to raise the average up real big. You talk about the median. Even if you go to Zillow and look, it says median house price in the neighborhood or zip code or whatever. So if it has one big number or one small number, you use the median. Which one gives, this one says, which one gives the most common year? The most common year, so I'm going to use mode for that. Okay. And the last thing here is comparing, what is this topic? All right, which measures of central tendency do not exist for this data? I can find the mean and I can find the median. You can always find the mean and the median. Does this one have a mode? It looks like it to me. 73 happens 3 times. I think they all exist. Okay. Suppose that the measurement 54, the smallest measurement of the data, were replaced by 12. Which measures of central tendency would be affected by the change? If I just changed, I need to screenshot this, I think. If I only changed, like my median would be, this is 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's my median right there, right? That's my median. Okay, so if I take away the 54 and I put a 12, does my median change at all? No, because 12 is still my lowest number. So 12, that's not going to change at all. My mean is going to change a lot. My mode's not going to be changed at all. It's just my mean. And C, suppose that starting with the original data set, the smallest measurement were removed. Which measures of central tendency would be changed from those of the original set? If I take that number completely out, though, if I take that completely out, then I just have, this would just be the numbers 57 to 97. I am going to change my median, and my mean's going to change by taking out that 54. The mode's not changed at all because my mode was, what's my mode? My mode 73 right here? Okay. Oh, wait, they all exist. So my mode 73. So the 73 is not affected if I change that 54. So you just have to play around with those and see which one does that. If you take out the last number and don't replace it, or the first number, if you don't replace it, the mean and the median change. But if you take it and replace it with another small number, then it is going to change that. And the last thing I got to do real quick, I did not think this was going to take like 50 minutes like this did, but I can tell by the look on y'all's face, y'all are really enjoying it. So the last thing, I didn't mention this last time, but the reason that we call these central measures is when you have a normal curve. We'll call this normal curve a lot later on, but this is bell-shaped or symmetric. Okay. When you have this, if it is perfectly bell-shaped and symmetric, the mean is equal to the median is equal to the mode. Everything is equal if it's perfect. That's why they say approximately, okay? So the mean, median, and mode will all be equal. Everything starts to turn this way. The more data you get, it always starts to have this shape where everybody starts to fall, like the majority of people fall in the middle, like average height. Like everybody's around, 5'7" to 5'2", 5'8", whatever. Males, I guess, females would be a little bit lower, but like you have that right there. So the mean, median, mode would be equal. This one, y'all remember which one this way is skewed? Skewed left, okay? So the mean and median is still going to be in the middle. So like the mean is probably, the median is probably still right here, and honestly, my mode is probably still very close to it, okay? My mean gets pulled way down here. So my mean gets pulled to the left, which makes my mean smaller than the median. It's still going to be towards the center, okay? It's not going to get pulled like way, way down there. It's still going to be towards the center. And then the last one, the skewed right. Again, my mean and mode, or median and mode don't get changed that much. This could be something like that, but my mean is going to get pulled towards that tail. So my mean is greater than the median, okay? Those big numbers. But this is what measures of center is about. You are talking about the center of that bell curve. What we're going to talk about next is how varied and spread out the data gets.